Good morning, everyone. I am Satanik from the Biomechanics section, Leuven, and today I'm going to talk about a multi-scale in-silico study of the interplay of mechanical and inflammatory cues in osteoarthritis. So osteoarthritis is a degenerative disease of the joints which affects more than 33% people over 65 years of age. What happens in osteoarthritis is undesirable differentiation of the stable articular chondrocytes or the cells residing in the articular cartilage to hypertrophy. And subsequently, the cartilage becomes vascularized, mineralized, and is eventually replaced by bone. And this leads to severe pain and loss of mobility of the patients. Now, if we are to study the onset and progression of osteoarthritis, we need to know what is the interplay of mechanical and biochemical factors that are happening at different length scales in the articular cartilage. And this can be done by using multiscale models. So the multiscale model that is developed in this project starts off with the knee joint model. A finite element model of the knee joint is developed with joint kinetics and kinematics from the stance phase of the gait cycle used as input boundary conditions. And this helps us in calculating the stresses and the strains in the different locations of the articular cartilage. And when these strains are used as input boundary conditions to a cellular level model consisting of the chondrocyte and its microenvironment. And from these models, we calculate the forces sensed by integrins, which are the mechanosensors for the chondrocytes. And then these forces sensed by the integrins are used as inputs to intracellular regulatory networks, modeling mechanotransduction. And as an output, we can calculate the activity of the biochemical markers secreted by the cell. Now, using this workflow, we wanted to study a pathological case, that is meniscectomy, or the removal of meniscus from the knee joint. And it is known to trigger osteoarthritis in a lot of cases. And we use the same workflow that I discussed before. And what we observe is that in the articular cartilage level, meniscectomy induces higher strains in the medial cartilages. And when these higher strains were used as input to the subsequent cellular level models for a deep zone chondrocyte, we observed that the maximum forces sensed by the integrins were higher in the case of meniscectomized knee joint, and when they were used as inputs to the intracellular mechanotransduction pathways, together with the presence of inflammatory cytokines, we observed that there was a phenotypic switch of these deep zone chondrocytes from a stable SOX9 positive chondrocyte in the healthy state to a more hypertrophic RUNX2 positive chondrocyte in the meniscectomized case. And this study highlights the efficacy of multiscale models in predicting the fate of articular chondrocytes due to the combination of mechanical and inflammatory cues, and can be used to predict the onset and progression of osteoarthritis in the future. Thank you.